Okay, so chapter 9 is about exponential and log functions. Logarithmic functions. Okay. And we're going to start with the definition of an exponential function. Now, exponential functions and logs, and I'm going to call them logs because logarithmic is a mouthful. So exponential functions, exponential functions and logs, they're actually inverses of each other. Now, we don't talk about that a lot in this course. You will in 1800, but they are inverses of each other. So, and you'll see they're very much related, okay? So here's a definition. An exponential function I said e function, but exponential doesn't have to just be e. An exponential function is written as f of x equals a to the power of x, where a is the base, and it can't equal 1, and x is any real number. Okay, so basically what's changed about what's different about this function? Can anybody tell me what is different now that we haven't dealt with before up till now? In any kind of meaningful way. You've seen it, but you haven't worked with it. Can anybody tell? You're like, no, I've seen it all. Okay, the variable is in the exponent. And like I said, you guys have seen that, but you haven't really operated with it too much, okay? So now with exponential function, how can you tell if it's exponential? There's a variable in the exponent and the base. Well, the base is a number, but the base can actually be a variable too. Those are a special kind of exponential function that thankfully you don't see till calculus. So maybe it's thankfully, maybe it's unfortunate if you like math. All right, so here we go. Graph. Let's look at what this looks like. Let's just look and see how do these things operate, okay? So let's graph f of x is equal to 2 to the power of x. So I have a number to a power. And I'm just going to make my t-chart. And some of you out there who had really good math classes in high school or were really good math students in high school, you might recognize already, you know what this is going to look like. But let's just plug in some numbers and see, okay? So I'm going to start with my wonderful 0. 0, okay? So f of 0, is 2 to the power of 0, which is 1, right? So this is the point 0, 1. All right, let me try 1. So if x is 1, we have f of 1 is 2 to the power of 1, which is 2. All right, so far that's easy enough. So that's the point 1, 2, input, output. All right, well, let's put in 2. X equals 2 means f of 2 is 2 squared, which is 4. And that's the point 2, 4. Wow, these are easy. Okay, x equals 3. F of 3 is 2 to the third, which is 2 times 2 times 2, which is 8. 3, 8. Sweet. So let's say x is 4. We'll do this one more. F of 4 is 2 to the fourth, which is going to be 2 times 2 times 2 times 2, which is 16. So the thing about exponential functions is you can see it doesn't take much. They can get really big, okay? If I put in 10, I'm not going to calculate it. But say we wanted to see where the point goes if x is 10. Well, f of 10 is 2 to the power of 10, which is huge. I don't even know that number off the top of my head. Big. Okay. So it doesn't take much, and as your x values get large, your y values get really big, really, really big. All right, let's look at what happens with the negatives. If I put in a negative number, okay, f of -1 is 2 to the power of -1. Well, that is 1/2. Remember, negative exponents mean flip it. 1 over, take the reciprocal, 1 over 2. So if I put in -1, I get 1/2. Okay, let's try -2. F of -2 is 2 to the -2, which is 1 over 2 squared, which is 1 over 4. Okay, -3. What do you think -3 is going to be? Can anybody just call it right now? Oh, you're not fast enough.
1 over 8.
Yeah, okay, good. 1 over 2 cubed is 1 over 8. So then what do you think -4 is going to be?
1 over 16.
Yeah, very good. You guys see the pattern going on here? So, 4 gave us 2 to the power of 4 gave us 16, but 2 to the power of -4 gives us 1 over 16, which is a very, very small number. I don't want to divide it, but 1 divided by 16 is 0.0625. So in the negative direction, this is getting very, very small. So whereas my outputs in the positive direction, they're like blowing up, the outputs in the negative direction are getting very, very, very small. So let's look at this graph. Let's stop screen sharing. Here we go. All right. Here. Okay. So I have 1, 2, 3, 4, -1, -2, -3, -4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10. All right, so let's just see what happens using these points, right? All right, so 0, 1, that's easy here. 1, 2, so over 1 up 2. 2, 4, so over 2 up 4. And then 3, 8. 5, 6. All right, now if I go to -1, that's 1/2. -2 is 1/4. I don't even know. I mean, you see these are going to get very, very close. Okay, so this graph is going to look like this. On this side, it's going to coast right along the x-axis. And then once it gets positive, it's going to shoot right up. So this is f of x is equal to 2 to the power of x. Now, it's important to know that this here, it rides along the top of the x-axis. But never crosses. What's that called? Just out of curiosity, you guys remember what types of things do that? So, starts with an A.
Okay, asymptotes.
Yeah, sounds like a bad word, but it's not. All right, so yeah, so this is a what we call a horizontal asymptote. At y equal to 0. Okay, that's all along that. So it's gonna get really, really close, but never cross it. And that's all I'm ever gonna say about horizontal asymptotes. Again, when you get into pre-calc, you will learn a lot more about them. But yes, that is absolutely an asymptote. Okay, any questions about that? Finding these points and graphing it, and what does it look like? Things to notice is that exponentials get big fast, increase quickly. And you know what? Have you guys been paying attention to how they talk about the spread of the coronavirus? That it's an exponential increase. This is what they're talking about. That it spreads very, very quickly and the numbers get big fast. So just start listening for that when you guys are, because I mean, they talk about it a lot. So, all right, example 2. Let's do one like this. F of x is equal to 1/2 to the power of x. Yes, we're gonna get to some fun stuff. I mean, not that this isn't fun, but all right, so here's my t-chart. So how about this? Let me give you guys some numbers. I want you to go ahead and see if you can figure these out on your own. 0, and we're just gonna do 1, 2, and 3, not 4. And then -1, -2, -3. See if you guys, I don't know why I made those so big. See if you can calculate them on your own. Okay, so I put in the positive ones. I'll give you like 30 more seconds to get the negatives. All right, so you should have gotten 1/2, 1/4, 1/8, and then 2, 4, 8. Okay, so it actually, you guys can see they're the flips of each other. Okay, so let's look at this graph. What would you expect to see? Everything, it's like opposite, right? Or reciprocals. Really, not really opposite. I hate to use the word opposite because opposite usually means sign. Positive, negative are opposites. But these are reciprocals of each other. Okay, so flips if you want to get, just use some basic language. So here we go. We have 1, 2, 3, -1, -2, -3, and I still have this 0.01. And what happens is 1, 1/2, 1/4, 1/8. And then, all right, so -1 is 2. -2 is 4, 2, 3, 4. And then -3 is like 2, 3, 4, 5, 6, 7. All right, like that. So now the graph, it's still following the same pattern. You should notice that this follows the same pattern, but what's different? Okay, let's look back at the first one. That was the first one. How is this one different?
It starts in the negative region.
Yeah, it starts in the negative region. And actually what Amariam put in the chat is right. It reflects around the y-axis. Do you guys see, like, if you could like take this graph, just imagine like smacking it and it swivels to the other side. I have a very visual imagination, a very vivid imagination, I should say. Okay, imagine taking this and like twisting it around the y-axis. It's called a reflection. So this is a reflection around the y-axis. So it does reflect around the y-axis. Oh, you're all in private chat. Thank you. I like to have it open to everybody, but it's left on from the test. All right. So it reflects around y-axis, but has the same shape. Okay. And so exponentials in general are going to look like this shape. They're either going to blow up to the positive region or blow up to the negative region. There's other things that can be done, other types of flips and shifts and reflections and stuff, but we're not going to get that into that too deep here. We're going to just keep it moving because 1050 is about doing a little bit of everything. And then as you go on to pre-calc, you kind of like dive in on a deeper level. All right, so that's going to take us to 9.3. Now, I don't remember what 9.1 is, but I don't think it's a big deal. I have to look back at it, but this is 9. So 9.2 is the exponentials. Yeah. There must be something introductory in 9.1. I have to look back at. So 9.3 is we start to talk about log functions. Okay. So here's a definition. Log base a of x is the exponent of a to get x. So notation, just some notation. We call this this a here that is called the base of the function. That's the base. And also there is a domain restriction here. This is the new domain restriction we're going to encounter. So far it's been no zeros in the denominator, no negatives under an even root. And now you have that the input of a log function, I'm going to call it in this case x, has to be greater than 0. And I'm talking about right here, this x, okay? Yeah, you can't have negatives and you can't have 0. You cannot put 0 into your log function, okay? No negatives, no zeros. Now, so another way of seeing this, I'm going to give you guys this too. I want to show you that. So log base A of X, if we say this is equal to a number Y, that is the same. This means this is if and only if, but both directions are true, is another way of saying this. Okay, so what this means is Y is the exponent you put on A to get X. Okay, so that's what I wrote. The log base A of X is the exponent of A to get X. So if we call that exponent something like Y, this is an equivalent statement. So A to this power of Y is equal to X. These mean the same thing. So let me show you some examples to illustrate that. Because this is kind of like, you know, notation stuff is weird. So let's do some examples. Find 1 log base 3 of 9. Log base 3 of 9. So here's the question. What is the exponent that goes on 3 that will give you 9? Everybody. 2. Yes, thank you, Sydney. Okay, and then look, 3 to the power of 2 is equal to 9. So you can see here, you know, this is this form, and this is that form. You guys see? Okay. It's the exponent you put on the base to get what's inside the parentheses. All right, let's do another one. Find log base 2 of 16. So again, what is the exponent? What is the exponent I had to put on 2 to get 16?
4.
4. Yes, very good. All right, here's 3. I'm not going to rewrite it every time. It's not necessary, okay? I want you guys to be able to look at this and do it. Sometimes when it's not obvious, you might have to look at it in exponential form. This is the exponential form, by the way. Remember, I told you these guys are really related, okay? Logs and exponentials are inverses of each other. That's why they look like there's a lot of overlap, okay? So let's do this. Log base 3 of 1/3 is equal to what? Okay, so what exponent would go on 3 to give me 1/3?
-1.
Yeah, -1 is 1/3. So there you go. It's -1. Remember, the answer is the exponent, which is weird. We're used to it being the output, which would be like, feel like 1/3, but it's the exponent. It's an exponent. Logs are exponents. All right, let's try this. Find log base 10 of 10,000. So 10 to what power is going to give me 10,000? So 10 to the 1,000 power is going to give me 10,000.
Isn't it 4?
Yeah, Nader's got it. It's 10 to the 4th. Okay, that's 10 times 10 times 10 times 10, which is going to give me 10,000. So the answer is 4. It's the exponent. Okay. All right, here's a challenge, guys. Well, not, yeah. Log base 2 of 1/8. A little bit of a challenge. 2 to what power will give me 1/8?
-3.
-3. Okay. Here's my challenge. Log base 10 of 0.1. Log base 10 of 0.1. Now this is one we might have to like like play with a little bit. So I want to know 10 to what power is going to give me 0.1. But what is 0.1 really?
0.10.
It's 1/10. It's 1/10. That 1 is in the tenths place. So you can rewrite 0.1 as 1/10, which means the exponent is really what? -1.
1.
It's -1, okay? So just realize that 10 to the -1 is the same as 1/10, which is also the same as 0.1. All right, see how good you guys are. Log base 9 of 27. Okay. If I look at powers of 9, that's not going to cut it, is it? Sydney says 0.3. That's good thinking. What if we did something that wasn't a whole number? Yeah, what is 9 to the 1/2? Let's start there. Instead of, isn't that a thing? What's 9 to the 1/2? That's square root of 9, which is 3. Ah, now 3 to what power gives us 27?
3.
Yeah, 3 to the 3rd is 27. So now let's put it all together. I feel like this is like a little Sesame skit, Sesame Street skit. If you have this and this, then put it all together, okay? So if I have 9 to the 1/2 is equal to 3, if I raise each of these to the 3rd power, I will get 27. So I see people putting it in the chat. The exponent is going to be 3/2. Questions? All right, how about this one? This one for fun. Square root of 7. The base is square root of 7. What's the exponent that goes on 7 that will give me square root of 7? 1/2. That's right. Okay. 7 to the 1/2 is the same as square root of 7. Questions? Okay. So they can range from, basic exponents to a little bit harder. Let's do one like this. Log base 8 of 1. What power would I have to put on 8 to get 1? 0. Very good. 8 to the power of 0 is 1. Any questions? All right, let's look at estimating logs. So I have about 5 more minutes. I want to talk about estimating logs. So again, you're not really supposed to use your calculator, and you want to have some sense of what these things are, okay? So let's look at estimate log base 3 of 10. Now, what I'm really asking is 3 to what power will equal 10? Okay, so what power can I put on 3 that equals 10? All these ones above here, we were able to be clever, okay? There was like straightforward, then we got some negatives, and then we were able to use our roots, our knowledge of roots to kind of get some of those. That's not going to work this time. Okay, you guys see, even if I have square root of 3 or I square, so we got to look at what the powers mean. Yeah, so you got to take an estimate. So 3 to the first power is 3. 3 squared is 9. That's not quite 10 yet, but then 3 cubed is 27. So that's a huge jump. But our answer is somewhere between 2 and 3. What would you say? 2 point what? Say like 2.1, right? It's very, very close. Like 10 comes right after 9. So the exponent has to be right after 2. Does that make sense? Any questions on that? All right, let's try a couple more. Estimate log base 2 of 20. All right. So again, I'm going to look at my powers. So I know that 2 to the 4th is 16 and 2 to the 5th is 32. It's twice 16. So where is 20? Is it in the middle though? So Cornelius, is 20 going to be right in the middle of 16 and 32? Yeah, it's closer to 20, isn't it? Or it's closer to 16. So if I put 20 in here, this is going to be about 2.42 or 3 or something. So I would say about 4.2. You guys see that? Okay. Something else I want to, let me give you guys, oh, let's do this one. This one's a doozy. Okay, ready? Log base 5 of 4. Now, 5 to the first power is 5. That's already too big, isn't it? I'm trying to get 5 to what power is equal to 4? So my exponent here has got to be smaller than 1, okay? Yes, when your output is smaller, then that means that my exponent's going to be about 0.8, okay? It's got to be smaller than 1. Any questions? So there's going to be times where you are asked to estimate logs. This is how you do it. I want to point out some notation in the last minute I have here. If you have just log of x, it is assumed to be base 10. Okay, and this is kind of like similar to the reason why square root is just the square root and we don't put a 2 in there. Our whole number system is base 10. You have 10 fingers. I think that's why, personally. I don't know. I didn't study the history on that, but maybe because we have 10 fingers, okay? So we have 0 through 10, and then hundreds, and then thousands. Everything is based on 10. So base 10, this is the notation. So anytime you see just log of x, this is the same as log base 10 of x. It's assumed. Okay? All right. I will make sure your homework for tomorrow and Tuesday is posted, and then anything else. I will be on at 5 on office hours if you want to come. Otherwise, have a good day, everybody. Bye.
You too.
Thank
Bye,
you.
thank you.